Okay, today we're going to be looking at graphing linear systems. Now, a linear systems simply means two or more equations. So systems of equations is two or more. We're just going to look at doing two equations. And we're going to find out that when you graph two equations, there may be one solution, no solution, or an infinite number of solutions. So let's look at some examples. Okay, again, we're going to be dealing with just systems with two equations, and they're going to be linear. That which you're familiar with, straight lines, those that are slope-intercept form, y equals mx plus b. When we graph two equations, the coordinate of the point where the two equations cross is the solution. So let's look at an example so we can make some sense out of this. First one, y equals 2x minus 1. It's already in slope-intercept form. So let's go ahead and graph this one. Y-intercept is at -1, and it has a slope of 2, which is up 2 over 1. After you plot your points, draw a line through it. And then we'll graph the second equation, y equals x plus 1. This has a y-intercept of 1. And remember, if it just says x, that's the same as 1x, which is a slope of 1 over 1. So we'll count up 1 over 1, up 1 over 1. And draw a line to connect those points. And the point where they intersect is the solution. It's right there. And the solution is always an xy coordinate. It's always in the form xy. So the solution of this then would be 2, 3. So by graphing, you found out where the two lines crossed, and that is the solution of your systems of equations. Now, as you've seen in the past, it's not already in slope-intercept form. And make a note on here to edit this second formula. This is 2y minus x equals -4. So yeah, make that change right now. So we're going to get both of these into slope-intercept form, graph them, and where they cross will be our solution. So in the first equation, subtract 6x, and divide by 3, and you have y equals -2x plus 3. Okay, our second equation, and hopefully you noted the change, is 2y minus x equals -4. We'll put this into slope-intercept form, add x, divide by 2, and you have y equals, and hopefully you realize that x over 2 is the same as 1/2 x minus 2. Now we'll graph both of these. We'll start with this one. This has a y-intercept of 3. And a slope of -2, which means down 2 over 1. And just draw a line connecting those points. And graphing this one, y equals 1/2 x minus 2. We'll start at -2. This means go up 1, right 2. And I think you can probably see right now where they're going to cross. So they're crossing right here at this coordinate, which is the coordinate 2, -1. Now in the book, whenever there is a solution, they use that term consistent. It simply means that the problem does have a solution. Now there will be some rare cases where it won't have a solution. Let's take a look at this next one. The first one's already in slope-intercept form. The next one step, we'll put it into slope-intercept form. So that becomes y equals 2/3 x plus 3. So we have two equations to graph. That one and that one. Graph this one first. You start at -2 up to over 3. And draw a line to connect the points. The second equation, y equals 2/3 x plus 3, we're going to start up at our y-intercept of +3. Again, it's up to over 3. And connect those points. Now, if you look at these two lines, what type of lines are these? If you said parallel, you're absolutely right. And from what you know about parallel lines, they do not intersect. And the point where two lines intersect is the solution, so if they are not going to intersect, we simply say there is no solution to this problem. Okay, let's move down to this example here. It looks like one step will get this one into slope-intercept form. And the second one. And 6/4 is the same as 3/2. 24 divided by 4 is 6. And there's our two equations. Now you note they're actually the same equation. If you graph, go up to the y-intercept of 6, up 3/2. And if you think about it, if you graph the other line, you'd be starting at the same y-intercept and counting off the same point. So what you would actually have is a line on top of a line. And to visualize what this means as far as what your solution is, a line on top of a line, the solution is where they intersect or touch, and these are intersecting and touching. They're touching at an infinite number of points. So unlike the last problem where there was no solution, in this case, we're going to say there are infinite solutions. Okay, in summary, just simply get your lines in the slope-intercept form and graph them. Where they intersect is your solution. If they do not intersect, as in when they are parallel lines, there is no solution. And if, like our last example, they turn out to be the same line, there will be an infinite number of solutions.